So, who's driving?
You can drive or I can drive.
You drive.
Okay.
I drove once.
So, good afternoon, folks. Welcome to the V6OPS session. This is Xi Peng Xiu. Today is the first time we have all three co-chairs here, Ron and Nick. And Matt is our AD. So I would like to read the note well. By participating in the IETF, you agree to follow IETF processes and policy. If you are aware of any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose the fact. Or not participate in the discussion as a participation in or attendees to any IETF activity, you acknowledge that written, audio, video, and photographic records of meeting may be made public. Personal information that you provide to the IETF will be handled in accordance to the IETF privacy statement. As a participant or attendee, you agree to work respectfully with other participants. Please contact the OPS team if you have questions or concern about this. Next is a housekeeping item. If you have not logged into MeEcho, please scan the QR code to sign the blue sheet. Also, please use your mobile to get into the queue before walking to the mic if you are in the room. Here, before we start to talk about the agenda, we would like to propose that we take a minute for Fred, because he was the V6OPS chairs. So we would like to propose that we take a minute of silence to remember Fred. Okay, thank you. So in addition to this chair presentation, today we have 3 working group drafts, 2 individual and 4 discussions. We would like to also give a quick status of V6OPS in terms of number of draft attendees and also progress. The number of drafts, I think for us over time, but now is more or less stable. But in terms of number of attendees, we find that in the last few IETFs, the number of attendees, while also stable, is kind of like 1/3 less than, maybe 5 IETF ago. Some suggest that maybe this is just frustrated, together with the total number of attendees in the IETF. But if you also have, opinion why the number of attendees dropped, please let us know, because we do like to encourage more people to participate in the working group. Since the last IETF, we advanced 3 drafts. One passed IETF last call, and now is in the RFC editor queue, and we have 2 more drafts in submitted to IESG for publication. Last, we continue to encourage people to contribute to the important works. These including the items listed in the milestone, and also Brian Carpenter's free book. We always encourage people to contribute to it because it's very important. There are some other tasks we're thinking of, including, for example, clearly define IPv6 only, because even up to this point, there's still different opinion what exactly is IPv6 only. Work with happy group to generate to get some logs when IPv6 is not selected. So, and also collect IPv6 traffic to monitor whether the IPv6 share is growing healthily or not. Because at the end of the day, traffic is most important. If you have, have 100% user capable but no traffic, then it's not useful. Last thing is to maybe start to document use case for using AI to support IPv6 education deployment or operations. We hope to see some drafts, for example, before next IETF, etc. So these are the chair's status. Ron and Nick, you want to say something?
Just another quick plug for the IPv6 textbook. We just pushed a new version. I just sent it over to the website this morning. So there's also now an EPUB version, if that makes it easier for people. The more folks we get looking at it and contributing, the better it'll be.
Jen Linkova, can you go back to the graph of number of attendees? So first of all, it would be interesting to normalize it by the number of total people attending IETF, right, because we don't know if, I don't remember at least from the plenary, if general participation dropped. Secondly, actually question to the group, how many people actually logged in, scanned the QR code or logged into on-site tool? Here you are, right? Here you are. Here are your measurement
That
results.
could explain it.
Yes.
So if you have not logged into Me Echo, please scan the QR code, or so that you appear on the blue sheet. Thank you.
Warren.
Jim.
Oh.
Hi. Yeah, can you clarify what you meant for the happy working group? I assume you mean it's the log reporting?
Well, Tim, I think that this may take a little bit time. Maybe we can discuss this tomorrow in the happy working group.
Well, it's Thursday is the happy working group. Geordie has a slot, but if it's about reporting, then there's many issues there. But yeah, okay, I was just checking what it was. Thank you.
Yes, I think that we discussed this in the past in the V6OPS mailing list, but we can.
I think it's being discussed as to whether it's a good idea to report via the browser or whatever's using happy cases where it doesn't behave as expected, or at least how it behaves so the logs can be analyzed. But there's all sorts of non-technical issues there as well that we need to be careful about. But if people are interested in that, please come to Happy on Thursday to discuss it. Geordie has a slot for it.
Okay.
So Warren Kumari, apologies, I should probably have asked for a slot for this, but I just want to make sure everybody knows the IETF network is now on IPv6 mostly network. Fairly much everybody's using it, and it's all happy. We have found so far 3 or so vendor bugs which we have reported, and they're working on them, but they were just small usability tweaks, and it all seems great. So thank you everybody for doing V6 mostly and making it all work.
One by one.
If everybody used a Mac, which is a plug for, hey, everybody get a Mac.
Or we get Windows completing the CLAT support. Yeah. Yeah. Just to complement or to clarify the situation with Happy Able, sorry, I am Jordi Palet. I think the confusion comes because I presented initially several years ago the Happy Ables reporting here in this working group because we didn't have a Happy Ables working group. So I guess that the work should be done now in Happy. And in fact, as Tim already mentioned, I am presenting the reporting ideas on the next meeting, I think is Thursday. So I am not sure we should do anything else here or just probably work together with Happy Ables if something is related to IPv6, but I think that's already within the scope of Happy.
Yes, as long as some working group is doing that work item, I think that's fine.
Yeah.
So let's move on to the first draft presentation. Tommy.
All right, CLAT recommendations again.
It's not working. Okay, thanks.
Okay, yeah, thank you. All right, so we made a couple of changes based on everyone's awesome feedback. Shouldn't take long. One of them is adding clarification to how CLAT acquires IPv6 addresses. We already said we're going to remove the dedicated /64 requirement, but then we specified in the dedicated prefix model, aka when you're talking about providing CLAT downstream from the node, that you have options, so that it was clear that we weren't being prescriptive about what to do in that scenario. Next slide, please. And then everything else was adding clarification to what we meant by one should treat CLAT addresses as you would any other IPv6 address. So all these reasons were already here, other than the italicized bit in the middle where we talk about process received unicast or solicited node multicast, so that there's not issues when those caches get stale. The reason you perform the DAD check is because in real life, some networks block access until you do. So it's not that you need to do anything with the result, but you really should at least start one. Next slide, please. And then the reason you send gratuitous neighbor advertisements is to avoid packet loss when you start talking after not talking, whether it's first connection or coming back from a silence. And then finally, registering your addresses using the recent RFC on informing a DHCP-v6 server on what your address is, so that you can enable better troubleshooting for the network operator. And that's it. So we think we're ready for working group last call for sure this time. But if there are any other issues, we're all ears. All right, then. Thank you.
Okay, then. What? It's time, huh? They want to make the decision. Yeah.
We're clearly turning carpets in the picture kucha, right? 20 slides in 20 seconds. Okay. Again, using how to translate untranslatable. Next slide, please. we've been presenting this many times, and I normally put like 7 slides explaining the problem statement, why we are doing this, but hopefully by now, everyone knows what's going on. In a nutshell, sometimes your CLAT can get an untranslatable V6 ICMP from untranslatable real V6 address, and it needs to present it to IFO-only application somehow. So we want to use special ICMP extension to preserve original V6 address, and we suggest to using this /29, which already reserved, /32, IPv4 address already reserved by IANA as dummy IPv4 address to present IPv4 address instead of V6. So changes since adoption, since last IETF. Next slide, please. So minimal changes, actually. We added more details on why the previous work on this topic is not going to work, actually, and why we're suggesting to deprecate 6791. First of all, because it recommends to use a single or multiple public V4 addresses to represent V6 addresses, which in case of, for example, CLAT running on your MacBook is not feasible at all, right? So it might work for some like routers doing translation, but really not for laptops. Next slide, please. Yeah, so draft, as you can see, has been very stable. It's very short draft. The int area draft, which defines the ICMP extension we want to use, is already past the last call in int area. So I think it's the perfect time for issue last call on this one. And I think Warren has questions or concerns or general unhappiness, general.
So maybe we can.
I was just going to say, why aren't you referencing that, or why haven't you noticed that it moved? But you already did.
Other questions? No?
No one in the queue.
Yours, right? Okay. We can say that the consensus is relatively clear.
Now can
Maybe
we ask
we'll
for the
move on.
last draft?
What?
Can we ask for the last draft?
Okay, the previous draft is the working group adoption.
Thomas was also last call.
Yeah, he asked for a last call too.
Yeah. We'll do another show of hands for Tommy since we didn't do it right after his draft. This one's also pretty clear.
Yeah.
Okay.
All right.
Hello, I'm Ben Patton, here to give an update on 7084 biz, which is updates to IPv6 CE router requirements. Next slide.
I did.
Oh, there it is. Okay. So a quick update on the changes between last revisions. Most of these are actually land-side requirements. First one being added a reference to the current Slack renumbering draft for CE routers to support that. There's a general requirement clarifying that link local packets shouldn't be forwarded by CE routers. Added a requirement for RFC 772. Specifically, this is calling out that IPv6 CE routers should be required to send unicast RAs in response to router solicitations on the LAN. And then the last one, I realized half hour ago, the last bullet sounds a little vague, but if you actually go and read L19, it's just defining maximum and minimum RA interval defaults. Next slide, please. So outstanding items, the big one is prefix delegation on the LAN side. Just general question for the working group on what exactly we want to say for that and what sort of requirement level we want to implement. And then just anything else that might need to be incorporated before we push this to working group last call.
We have some folks in the queue first.
Oh, sorry.
Bob's first.
Well, I'm not sure this is winning. Bob Hinden. So I looked at the draft a bit, and the first thing I noticed was that one of your changes is that you're updating to the current version of IPv6 node requirements. So, but 6man is now working on Abyss for that. So I think it would be really unfortunate for this document to be published soon and point to the old node requirements. So I think you need to take a look at that, and probably means you're going to have to may have to wait, but you know, you need to look at the changes that are going into the V6 node requirements. And I think generally you probably also should take a closer look at what 6man has published as RFCs in the last couple cycles, because there's been a bunch, and I think a number of those probably affect what's in here. I didn't look really closely, but you know, there's been a bunch of RFCs, and there's a bunch of like there's a document that affects ULAs that's now in the RFC editor queue. There's a number of things that are coming about. Our RFCs are about to be published as RFCs that you need to be looking at and see how it affects this document.
Fair point. Yeah, the authors will go back and re-review node requirements. And
yeah, unfortunately, as the author of both this document and node requirements, I'll take the heat for this one. So the deal here was I thought this document would finish way before node requirements finished, but I could be wrong.
Ted Lemon. So PD on LAN should be a must. There's no excuse not to implement that at this point, and it would cause dysfunction to not implement it. So it should be a must. Must be a must. And yeah. And in addition to what, as far as what we should say, we should make sure that PD on LAN includes a couple things. One, it has to say that routing has to work. So in other words, if right, maybe it sounds like I'm preaching to the choir here, so maybe I should just shut up. But you get the point. It's got to work. So.
Yeah, Lorenzo Colletti. I wanted to reiterate that reading should work. In fact, in fact, we should get that into LAN PD if at all possible. I know it's in whatever Auth 48, but like saying something like must forward the packets regardless of incoming interface, we should say that, because I have seen boxes that don't do this, and so we should really try and get like LAN PD. We could get those 3 words into LAN PD. I'm not sure this should be a must, to be honest. You know, especially for ISPs that hand out 64s, there's nothing you can delegate. But you know, anything else that needs to be incorporated? We get a lot of bugs on Android for broken CPs. I don't know how much of these are actual CPs, but a litany of some of the things that we get are like, they send NSs, they send NAs without the RBIT, and we fall off the network because that's what the RFC says we're supposed to do. Then another thing that they do is they send RAs with a lifetime of 10 minutes every 10 minutes, and we fall off the network because that's what the RFC says we're supposed to do. They get bridging wrong. This is hard to say. And the other thing that they do is like they send RAs way too frequently with lifetimes that are way too low. I don't know what we can say here. But I think we do need to say something. Like I've seen some ISP CP send RAs with a 12-second with a 12-second lifetime, and they complained that Android didn't work correctly, and there's no way to make it work correctly. So I don't know if this is the document to put those statements. I think maybe we need something in 6MAN because a lot of corporate networks get these wrong, but having it here would help. Because I think if it's in here and it's just incorporated with a set of tests, then maybe these bugs will go away. I don't know if we can get this stuff in here because it's obviously, we're basically saying don't violate the RFCs. Because if you send an RA with a lifetime of 10 minutes every 10 minutes, that's clear violation of 4861 already. But I think maybe, I don't know, Tim, maybe the fact that we don't have it here means we can't test for it. And if we can't test for it, we're doomed. I don't know.
Tim Winters, QA Cafe. So a couple things. To Lorenzo's point, I think there are a lot of V6 RFCs now. 7084 is where almost everybody building a home gateway starts. And so I think if there are things we want to clarify, like router lifetime, I think this is probably the appropriate document to give some advice. Yes, I'm aware of operators who are setting very low lifetimes. We get requests all the time for creating tests for those. They do it for various reasons. Sometimes I think they think it'll help connect their users faster. Not saying that it makes sense, but that seems to be the prevailing logic. So I think we could give people a little bit of help there, saying, hey, set the lifetime higher, you'll be happier. Everyone will be happier. I think that one's easy, so we should probably make an issue for that. And then for PD on the LAN, I agree with Ted, but at the same time, I feel like most home gateways don't do this today. I think should is where we should start with this. In spirit, I would love to make this a must, but my brain tells me it should probably be a should, and we should move that direction. Is sort of my position on this.
Ted Lemon, since I was mentioned, we should say what we think the device should do, not document what devices do. What the device should do is it must support PD on LAN. If there's a device that doesn't support PD on LAN, no, the device must support PD on LAN. If it doesn't support PD on LAN, it is compliant with RFC 7084, and it is not compliant with RFC 7084 BIS. If we don't say what we want, we'll never get it.
How am I arguing with you about this? Well, as the author of that draft or that RFC, it feels weird for me to be on the other side of this. Yeah, I mean, if everyone's cool with musts, we could give it a shot, but I don't feel like we'd obviously have to put a wrapper around you're only doing /64s. You have a way bigger problem at that point, and we can put that in there. If we can deal with that. I'm just surprised people really want to do musts on PDs on the LAN side.
Andrzej Saletka, RIPE-NCC, and IPv6 CPE user. Regarding this PD on LAN, some tips that I would say should be there. First of all, I agree that it must do, even if maybe in some deployments it's not useful because they do stupid things, the ISPs. But this is general requirement for home CPE. It should must do it. I would also say that it should say that the pool for the PD on LAN should be sized appropriately to the size of the upstream delegation. So if the device receives /48 from its upstream, it should not offer just one /64 to the downstream router, because I saw this. And second thing is that if the pool is depleted, there should be some way how to recover from this other than factory reset, which is also the real world scenario.
Yep. Thank you for the comments. Authors will discuss that.
Jordi Palet, and also as a co-author of this document, I think we should have, we must have a must, okay? If this is being broken because some ISPs are doing incorrectly their job, that's a different problem, and we should tell them how to do it correctly. But maybe this helps because it's breaking the deployment. This helps them to understand that it's broken because they are doing something broken.
So Warren Kumari, yeah, I think we can say things like, you must do this, but maybe somewhere in the document towards the beginning, we say, in order to be a fully functioning and useful home CPE, you must do these things. We realize this isn't fully implemented everywhere yet. But then to Lorenzo's thing, I think we can add in a bunch of like, there's a crap load of documents. I think the technical thing is a royal crap load. And so wherever people are missing stuff, we could have a like, you should also know that in a bunch of RFCs, these bits are required. Because otherwise, talk to the mic. Otherwise, expecting people to read all of the RFCs, I think, is too hard. So wherever people get it wrong, just be like, as noted in blarg, do X.
Yeah, so on the mustness of the PD on LAN, right? So here's a couple of things I've seen them get wrong. I've seen it hand out the on-link prefix in the PD. And I'm like, you're awesome. Like you win the prize, right? So are we going to say must not do this? Does LAN PD say must not do this? Yes, it does. It does. Okay, cool. Why did you feel that was necessary, Tim? Okay, good. Right. So my only question is, if it is must, people will do it and they will do it wrong. So we're going to have to be very careful about all of the things that we think they're going to get wrong so that we don't poison this. Because I don't want to have to write workaround code for buggy CPs that give me a broken PD. Because, I can see that coming, right? And so we need to be, and to the other thing I would say, now that we have the hood open, Ted, do you have any idea of like what things might like creatively break Snack? If you do, then you should like handing out the on-link prefix. Yeah, but there's a lot of other things that they could do, right? RA guard or like, even okay. All right. So anyway, that was my. I think we already say don't do it, don't we? Does it say don't do RA guard? Maybe. Yeah. It's more enterprise feature than CPU. Well, okay, so maybe for the notes, let's say maybe we want to say don't do RA guard in order to support Snack. Well, I mean, if it must do PD, then maybe that's fine. But anyway, that was my point, right? If we say must, let's make sure that the docs are very clear and like bugs don't show up.
Yep, fair point. Sounds like a lot of people are still in favor of must, even if it might break things, as long as we're careful. But
Hi, Bob Hindit again. I'm not completely sure it's appropriate here, but I would really like to see this also say something about hop by processing, hop by hop option headers, like don't drop packets with them, and ideally follow the instructions in I forget the RFC number, 9,000 something, that you should have the ability to process like at least one, and because a lot of routers like this don't drop packets or don't do them at all or other bad things.
Tommy Jensen, unaffiliated. I really think it must be a should. We only had one combination left. Because if we make it a must, we are implying that clients can fully depend on this always being present, and future documents do not need to account for the situation where there is no PD on the LAN. If we're ever going to write guidance for what clients should do, then it's not a must. It becomes a must, but we know you won't. We shouldn't do that. We should say should, must say should.
Sorry, what it means to say must is that the implementation must support the behavior. If you don't get a delegation that you can subdivide, then you're not going to subdelegate, and that's a very common case. So code that assumes that PD will always work is obviously broken, even if it's a must. Sorry.
Then that should also be clarified in the text. If we're going to talk earlier about not having people say that, you know, reading RFCs is hard, that will also need to be clarified. Which is weird.
All right. We're out of time on this one. I suggest we take it to the list.
Sounds good. Thank you.
No.
It doesn't.
What is it?
It's missing.
Okay.
It's missing.
Anyway, so yeah, this is me, Untitled Chapter, and I have this very short draft about a very practical issue that is basically that, yeah, there are still people that are using only v4, and yeah, we want to run our internal services over v6, so we have a VPN that has v6 that pushes routes to your client. You have v6 routes. Everything should work, but it doesn't because DNS just doesn't resolve Quad A records because the host somehow decides not to do it. So next slide, please. You end up in this weird situation because to make things even more complicated, this is the example from macOS. Different system utilities are using different resolver APIs which are behaving differently. So in my case, the IPv6 only domain name can respond to ping. You can do host and resolve it, but if you curl it or if you run it in Safari or Chrome, it will just say it doesn't resolve because different APIs are behaving differently. Next slide. So why? Well, in my opinion, you know, DNS is a database and you should basically get the same data from the database no matter what. But apparently the vendors of operating system have different opinions. So the reasons why they try to hide Quad A records from the applications, I found at least two of them. One is that if you have Teredo, which at some point in time Windows had by default on every single device, and this is your own IPv6 connectivity, then you better hide it from applications. So that's why Windows didn't resolve Quad A queries when it's only at Teredo. And something that I read from the source codes of Chrome or browser, because it's also a resolver apparently, is that they say that some poorly written resolvers might crash if they are presented with Quad A queries. And I think this claim didn't age very well with now Chrome doing HTTPS queries, because if some resolver crashed with Quad A queries, what probably the resolver does with HTTPS query. Next slide. So, well, in place of saying that not doing Quad A queries is bad, I just decided to go in positive way and basically write down how I imagine that the filtering of queries should be done in a way not to cause any harm. And I did it in a universal way. So I foresee a situation where you have a dual stack host, like your computer, connected to pure IPv6 only network. That means without NAT64, without DNS64, without any IPv4 support. And in that case, there's completely no point to sending out A queries because you don't have any way how to send IPv4 packets. So yeah, the draft has two proposed algorithms. One is basically look into your routing table, because if you can send packets there, it has to have root in the routing table, including connected routes, which I learned that is like implementation details on some platforms. But anyway, basically, if you can send packets there, it has to be in the routing table. If it's in the routing table, that means you should do the query, because you might get answer that will create a packet that is deliverable. The other option, and which is basically almost the same, is looking at IP addresses on your own interfaces. Again, if you don't have any IP address from that particular address family, you probably can safely stop doing queries for that particular address family, because yeah, why would you do it if that? The important part is, yeah, not to look just at the default route or default interface, because in our case, yeah, we don't push default route through the clients. We are using split VPN. We are only pushing several routes via VPN that are v6. So if you are on v4 only network, you will not get v6 default gateway. Next slide, please. Yeah, that's basically it. So now I wonder whether, yeah, this is a good idea, bad idea, or completely wrong, or whatever.
Okay, Jan Linkova, I apologize for not copying this group and you in person and my email to Happy Eyeballs, because as I said, this draft overlaps with what Happy Eyeballs draft currently says. Happy Eyeballs explicitly defines what queries to send if you have connectivity over given protocol. Your draft seems to be also defining that and also defining what connectivity actually means. So as I said, you probably want to talk to Happy Eyeball people to make sure that there is no contradiction, or maybe you guys can merge. Also, I just realized that our CLAT draft also was trying to define what connectivity means. So maybe this draft can be just renamed and only focus on defining what connectivity over the protocol version X means. So other drafts could refer to this and say, okay, if you have V6 connectivity, V4 connectivity defined by this, you can do something. Maybe it would be much more useful in general. And then maybe Happy Eyeball draft can refer to your draft saying, if you have V6 connectivity as defined, send those queries.
Okay, thank you for your comments. The first point is, yeah, in Happy Eyeballs, indeed, there is quite overlap. On the other hand, I would not like to have it only in Happy Eyeballs, because not everybody implements Happy Eyeballs. There's, and if you just, if this would be only fixed in Happy Eyeballs library, which is like, yeah, it adds another level of complexity of doing things regarding, let's not say NAS64, then it will still break the very simple cases or very simple application that is not using Happy Eyeball library or high-level system calls.
Yeah, so maybe my point is that you just need to make sure there is no contradiction between two documents.
Definitely, definitely.
Yeah, Lorenzo Colidi, I agree that the problem is get outer info, right? Get outer info has this thing where it's a blocking call and it returns and it has to return everything and it has to return it in the sorted order. And the resolver really doesn't know what you want. And so, I mean, Android does it as it does a V4 lookup for 8888, literally. It does a routing lookup for 8888. And then if it gets a success, then it issues an A. And for V6, it issues a V6, a routing lookup for a V6 address. And if it finds it, it issues a quad A. I think, sounds like you're suggesting if there's any route in the routing table that is V6 global space, then you should issue a quad A. I guess that's reasonable. I think it's very difficult to implement, though. But yeah. The other one, based on the IP addresses, I think you'll fall foul of various broken configurations. I mean, I went into some like apartment and it had like FD03 : and it had the ULA address, but it had no default route. The problem is always these broken configurations.
Yeah, like I also think that the looking at routing table is better in the sense that routing is changing much faster than addresses. Even like host configuration, addresses are much more stable. The default lifetime is much longer than the routing. If I only look at the default values of this thing, but yeah, I still think like, and I want to stress that I think it's completely okay also not to do any filtering and basically send A and quad A every time.
That's not okay.
Why?
Because it takes too long.
Even if you have Happy Eyeballs and doing it in parallel?
You said you didn't want Happy Eyeballs to be a dependency. So the problem, no, the reason it takes too long is like from like the stats we have on Android say that 7% of the time the DNS query needs to be retransmitted. And so that means that we've got basically 7% packet loss. Even if you issue the two queries in parallel, you're still 7% of the time, you're still waiting the retransmit timeout for the quad A to come back. And on a V4 only network. And that's not something that implementations are willing to pay. Right? So no, it's not okay to just always send them.
All right, that's an interesting point. Good to know. I wonder whether we can somehow then refine it in a way that it will at least not break the cases of like having some internet work. But I think like having a network with broken V6 connectivity would be like, it's not unavoidable. So like if you have IPv6 route that is black hole, but you have it, you will probably do queries and it will probably, yeah. But probably if you have broken V6 connectivity, you have much bigger issues with user experience.
So Nick Braulio, Energy Sciences Network, no hat. I've run into this problem extensively, specifically with VPN clients, and to work around it, we've had to build some very ugly scripts that add ULA addresses to VPN interfaces, and just, it's very gross. And I do think that this is a problem space that needs to be addressed. So I would encourage folks to continue to look at this because it is a problem.
Okay, thank you.
Tommy Jensen. Part of the justification right now is performance-based in the fact that there are multiple messages being sent. I'm not saying that the simple answer here is use multi-query type, but it would be interesting to reference multi-query type in the context of when that is sufficient to just always query A and quad A at the same time and have a single message versus, no, we actually wanted the stub resolver for some reason to never give back this address intelligently. Those are two different problems. Multi-query type may solve one of them.
Okay, thank you. I will have a look at it. Thank you.
So, even though there's some different opinion, but seems there are a lot of interest, so we will. Okay. So I think that it's pretty clear. Let's move on to the next item. Jordi, it's you. No.
Okay. So I think it was in Dublin. Yeah, I didn't have time to do this before. In Dublin, I already introduced the idea of moving to full standard some of the documents, specifically those related to NAT64. I looked at all the documents and the requirements for moving them to full standard, and basically we need to fill up a kind of form with 4 points. The first one is answer the question if they are widely deployed. Clearly, NAT64 has been widely deployed. The second question is if there are erratas that will cause interoperability problems. In my opinion, and this is something that probably we need to bring the discussion in the list, in my opinion, the 2 erratas that have been reported for NAT64 don't create new interoperability problems, so that will be okay as well. The third point we need to respond is if there are unused features. It's not the case with NAT64. And the last one, if there are patents, and in the case there are patents, if there is an easy way to sort it out, or there is a license feature or system that allows different implementations to coexist in an easy way. And I think that's also the case with NAT64, because we all know that NAT64 has been implemented almost by every vendor, and we don't have any problem. So that will be the first document, NAT64. If we believe that any of the erratas really creates a problem, I understand that the way in that case will be to fix first the document with the errata, and instead of going to this very short form, have like a NAT64-based document to resolve that. That's my impression. I tried to find information, but it was not very clear, but I think it's pretty obvious that will be the way. The second document related to this, let's say, set of documents will be the IPv6 addressing of IPv4, IPv6 translators. And in this case, there is not any issue like in the ratas that we had in the previous one for NAT64. Next one. Then we have also IP ICMP translation algorithm. And here we have the same, we have two errata. We don't have in-used features, and we have also a pattern. But again, this is implemented everywhere. For example, NAT46 stateless is using this as well, and we know that we have multiple implementations of CLAT, etc., etc. So again, I don't think there is a problem here. Next one, and I think it's the last one. And the last document is explicit address mapping, which typically it comes in any NAT64 box or firewalls that allow this matching of addresses in an explicit way. Again, here there is one errata. For me, it's clear in this document as well that this errata is not creating interoperability problems. But again, this is something that we probably should discuss in detail in the mailing list. And I think that was the last slide. Basically, what I am asking is if we have questions, inputs, discussion on the ratas probably. And then what I am not sure here is if we should go for working group adoption or then we bring the thing to the ISG, or I am not really sure about the process, but I guess that at least we need to have a way to say, yes, the working group is happy with doing this, right? Yeah.
Bob. Hi, Bob Hinded. So when we did all the work in 6-man to like move the IPv6 back and the others to standard, we went through we incorporated all the updates in a new version, and we also went through all the errata. So I mean, some of them, yeah, there's like different kinds of errata, and some were obsoleted by updates. So you have to sort of evaluate them, but you do need to process them. And then I think the thing is you just, the document says it's moving, desired goal to be standard, and you advance it in the normal way.
Exactly. The thing here is that unless I am recalling now wrong, there are no updates to any of these documents. So it's only the thing of the ratas.
Jen Linkova. Yeah, I actually have a question about the process, because my concern is that for some reason, because NAT64 FC refers to 6145 as an algorithm, which been obsoleted by 7915. But for some reason, 6145, when I look at this, does not say obsoleted by, which is very confusing, and I believe might confuse implementers. So I'm wondering if it worth publishing BIS and changing the reference to 7915, make it explicit. Because yeah, it took me a while to discover that I actually should be looking at like 7915 instead of 6145.
As said, I think from the 4 documents, one of them is clear. The others depend on updates or erratas. As you say, one of them might require a BIS. I am happy to work on that. I can ask the XML to the reps editor and just process that. So if the working decide that's the way for the NAT, I guess you are referring to the first one, the NAT64 itself. So I am happy we need to do that with the NAT64 and progress with the other 3. But again, I think that in the case that there are erratas, there need to be a discussion, not just my opinion, about if those erratas need a BIS, need some kind of the date or clarification, or it's clear enough and we should do nothing about that, okay?
Philip Teasel. Speaking about weirdness in these RFCs, there's in 6052 the nice table of the different address formats, and to my knowledge, there's only one format ever used, the one with /96.
You mean the /96 versus other prefix lengths? No, there is usage of other prefix lengths.
Okay, I've never seen that.
Yeah. In real deployments, I can tell you we are using it.
Ron Bonica, HP. This may be an off-the-wall question, but what does advancing these buy us?
I cannot hear you, sorry.
I'm sorry. I forgot. Ron Bonica, HP. What does advancing these to full standard buy us?
What? I don't get your question. What is the?
What's the
Why? Because I discussed this I presented this in Dublin. The idea is how is possible we have the most used protocol, which is basically NAT64, which 464XLAT, not being full standard, while other protocols that are not being implemented so much, are even just standards. Okay, so NAT64, if I recall correctly, is informational. It's not even a standard. Is a standard? Well, some of the others maybe. Okay, so the idea is to have all them in the same status.
My question is, for the purposes of deployment, there's very little difference between proposed standard and full standard.
I don't agree. This is the same reason we proposed IPv6 itself to full standard. Yeah, I think it's a good sign, and I think it's important to do that.
Jelinko hijacking the queue. I actually do suspect, a lot of implementers could not differentiate, and actually it's not even clear when you look in RFC. It's a standard track, and you actually need to know the difference, right? So I do not think it biases us a lot, but it's harmless. So.
It's harmless, at least, yes. Okay.
Warren Kamari. Yeah, I mean, I don't know if IPv4 is a full standard, or DNS is a full standard, or BGP is a full. I don't think any of them are really, because I don't.
Well,
actually,
that's our fault. It should be. It should be, I guess.
Bob Hinton, I'll make one pitch for why it's maybe useful. So especially documents that have updates and errata and reference changes, having a new clean document that someone can read and get the current state can be useful, as opposed to having to follow all the history and all the metadata. So there is some advantage to that if it depends on the state of the document. When we did it in 6-man, I think all the ones we advanced, we did abyss, except for one. I think it was ICMP that didn't need any changes, and that didn't get republished. Just the state changed.
Yeah. Yeah, which and I understand that the state change is again done by the ESG if the ESG reaches the consensus of the working group of going forward, right? Yeah.
Ron Bonica, HPE, no hats. I agree with what Bob just said. Sometimes abyss is a good thing to clear out the errata, to clear out the updates. That's a totally different issue than the additional push to make it full standard.
Yeah, and again, I am happy to do abyss if we believe that any of the documents we need to clear the errata with abyss. So I am happy for that way. So we will raise the discussion in the mailing list probably one by one to separate. Yeah.
Yes.
Yeah.
Yes.
Thank you.
Jane, it's you again.
My apologies, me and Comic Sans again. So this weekend, we did some testing on widely discussed topic about how well our end host operating systems behave when you have multiple routers, multiple prefixes on link. So yes, so a bit of theory in case you do not remember. If you have multi-homing environment, and explicitly we are talking about single link with multiple routers, multiple prefixes. There are two key elements for a host to work correctly. First, it's Rule 55 of source address selection, which is crucial when host needs to send a new flow and selecting for a given destination what source address I'm going to use for that. And it's basically a Rule 55 saying you should prefer address from a prefix advertised by the next hop. So basically logic is I want to talk to google.com. I got a destination IP. Now I'm selecting next hop for that IP. And now I'm looking what prefixes were advertised by that router, and I'm selecting a source address from that prefix. Next slide. yeah, so basically here is an example, right? There are two routers with pink and blue prefixes, and after the host selects a pink router as a next hop, it should, if it implements rule 5.5, select the pink prefix and pick up a pink source address. And by the way, in this particular example, if the host does not do rule 5.5, it will actually pick up a blue source address because of rule 8, which tells you use the longest prefix match between source and destination. So it's actually very easy to test. So next slide, please. So the second element is what is one of the things described in RFC 8028, which says when you already have a source address, and it could be a source address is hard-coded, or for example, it's a return traffic, so TCP connection was open to the given address, right? How do you route it? It's important that you are not sending it to any default gateways you have, because it might be a router which belongs to different ISP and your packet will be dropped. So 8028 says for each prefix, the host should maintain a list of routers you can send those packets to. The only implementation we are aware of which implements this uses destination source routing, which was actually discussed today in the routing working group, if you were there. So basically, yeah, the interesting cases, as I said, when you need to send a packet with predefined source address for existing flow, or another interesting case, again, you have an existing flow and your topology has changed, new router appears, where that packet goes. Next slide, please. So yeah, here is an example. You have, again, pink and blue prefixes, and you want to send a packet from a blue prefix. And if you support 8028, you should select R2, blue router. While if you do not do this, you will prefer a router with a higher prefix. You send it to the pink router, and if that router does BCP38, your packet will be probably dropped. Not a good idea. Next slide, please. So why we decided, actually, why David spent 2 days doing work and I was running around distracting him with stupid questions. Because, yeah, every time we're talking about multi-homing in IPv6, we mentioning rule 5.5 and then like, no, it does not exist. And because it does not exist, we cannot do multi-homing, and implementations do not exist because nobody does multi-homing. So we decided to test rule 5.5 behavior because there were rumors about some operating systems actually supporting it. And we also decided to look at 8028 support as another key element, and also look at how well route systems behave when your topology changes. Because as I said, it's important for multi-homing, it's important for flash renumbering. And I have vested interest because my 6-man draft Gula actually talking about scenarios when routers appearing and disappearing and how well hosts could react to flash renumbering if each prefix corresponds to dedicated logical router. Next slide, please. So David prepared a nice diagram of the physical topology, which I stole from his hackathon presentation. Basically, yeah, if you have any questions about this slide, go straight to David because I have no idea what I'm talking about. So he wrote some Python code, which basically client connects to Wi-Fi, opens the web page, and the web page has a links for different tests. And when client connects to click on that link, JavaScript does some magic, and client gets arrays from Python code and opens some connections to some destinations so we can see what addresses were used for those connections and how host reacted when it asked, for example, to open a new connection. Yeah, I know David put that code on GitHub, but he told me you cannot run it without talking to him because it's very confusing. Next slide, please. So logical topology. What we have, what we try to emulate, is basically 2 routers on a link and two destinations behind those routers. 2, because we want to make sure we can differentiate a rule 8, longest prefix match, versus just using rule 5.5. So we know that it's not just accidentally, the host accidentally picked up the right router or the right address. And by the way, we had two tests. In one test, we were using routers sending default routes, advertising themselves as default routers. And in second test, we were using RIO to indicate that destination is reachable through that router. Next slide, please. So basically, yeah, what we did, we wanted to look at how hosts behave when there are two routers and two PIOs. So which source is selected for a given destination. And then we wanted to see, okay, we have already defined source address, which router will be used. And then we were doing some variation of topology changes. We deprecated RIO, deprecated PIO, and made router disappears by either explicit signaling, router was sending array with lifetime 0, or implicit signal when router stopped responding to NS. So basically, router gone away, or basically it's what Gula draft suggests. Your router, when prefix disappears, the corresponding router disappears. Next slide. So devices, what we tested. We tested macOS 15.5, Windows 10. It's very hard to find a Windows machine with IPv6 enabled, by the way. Among IETFers, at least. It's hard to find Windows laptop, and when you find a Windows laptop, most of them have V6 disabled. So we got Android 16, Chrome OS, and different varieties of Linux. One was Linux machine with array processed by kernel, and then David wrote a patch for supporting Rule 5.5. And so we had another machine which is supposed to behave correctly. And we tried to use Network Manager. And in a few slides, I'll show how well it went. Next slide, please. So Rule 5.5 test in details. So we asked client to connect to an address. And that, from longest prefix match perspective, blue prefix should be used. But from Rule 5.5 perspective, the host should be using pink prefix because the pink router has high router preference. So first test will to ensure when both routers are present, which source address is used. Then we deprecated R1 by setting lifetime 0. Then we deprecated pink prefix, and we made around R1 stop responding to NSS. And then we asked client to connect to the destination and and we made sure that it's using the correct source address after router disappears. So it switches the source addresses based on what router is present on link. Next slide. So how did we do test 8028? So initial scenario, you have one router, but host has two addresses, pink and blue. But we have only blue router. In this case, of host which is already implements Rule 5.5 will be using the blue source address to connect into any destination. And then a router with a better router preference appears on the network. And in this case, host which supports 8028, for blue prefix, it only has blue router in the default router list. So it will still sending packets to the blue router. But hosts which do not support 8028 will switch to a new default gateway. So it was a pass and fail criteria. Next slide, please. So, result summary. So, Apple, macOS, and Windows doing great for Rule 5.5 support. Well, there is a minor detail I'll tell about it in macOS case. And they behave correctly when topology changes. So we found almost no issues. And yeah, 8028 basically non-existent in those systems, which actually means, yeah, that as soon as Windows starts supporting V6 option 108 and CLAT, it will be another perfect candidate for V6 mostly enterprise networks, because yeah, even like topology changes and multi-homing actually would work. So we only need to deal with Linux because, as you can see, all Linux-based operating systems are not very good when it comes to multi-homing. David's patch, thank you, David, works just great What, David? Well done. So yeah, there are some work needs to be done because yeah, we found that if PIO is deprecated, there are some details which needs to be cleaned out. Network manager. Well, next slide. I come to it. So basically, as I said, Rule 5.5. Most common operating systems in enterprises doing very well, but no 8028 support, unfortunately, which probably means that if you have like topology changes in multi-homing, they might not be doing very well, but at least for new connections, they should do the right thing. Linux-based, yeah, we'll need to wait until David completes his fantastic work. However, there is a network manager thing. Next slide, please. So what network manager does, well, as David said, doing network manager things. So when network manager sees multiple routers, even if they advertise different preferences, it just creates one default route with ECMP and just starts sending packets somewhere. Like, yeah, network is a black box, please deliver my packets, I don't care. So we just started testing it. When we saw it, we basically gave up on testing devices with network manager because what else can we do here? So yeah, so no hope here, to be honest. So next slide, please. So yeah, if anyone knows people who write network manager, I would love to talk to them. So we found interesting corner case with macOS. So when there are two routers present on a link, in our case, it was higher preference for pink router and lower preference for blue. macOS installs default gateway, and then we deprecate R1. We set lifetime 0. What happens, macOS correctly installs a new default route for backup router, but for some reason, that router is installed as scoped to the interface. So nothing works until that router refreshes information with another array. That moment, everything starts working, iflag in netstat is cleared, and so on. We have reported that amazing corner case to Apple, and we're looking forward to seeing it fixed. Next slide. So yeah, so conclusion, Rule 5.5 is actually already here, just not evenly distributed between operating systems. Linux people needs to catch up. I'm actually a bit scared because like there are so many different things in Linux, like network manager and maybe some other managers. There's a problem with managers, which going to complicate things in multi-homing environment. So next slide, I think last slide actually. Yeah, so what we did not do, we wanted to do is to test CLAT. We know it's going to fail because as far as I know, all implementations just pick up one address for CLAT, even if you have multiple routes, and nothing good going to happen if you start changing topology or have multiple routers. But we are open to hear other suggestions, what we missed in our test cases. And that's all. Lorenzo.
So you won't hear me say this almost ever, but it's actually not network manager's fault.
Not my fault, right?
So
Okay.
the problem is that like Linux just won't let you configure two routes on the same, two default routes on the same interface with the same metric. And like the kernel just doesn't support that. So,
but
like,
wait, can you go back to the test results? But why when?
Because autoconf is magic. It uses internal in-kernel APIs that don't have this problem.
But why our normal Linux, like with array being processed by kernel works?
Because the kernel code uses internal APIs that user space can't use. And so network manager, even if the network manager folks wanted to fix this, they couldn't because the kernel doesn't have the APIs. Anyway,
so it's a kernel problem. So the kernel needs to be fixed.
But then network manager needs to be fixed afterwards. But then it will become their fault. One thing I wanted to say is if you go back a couple, maybe to the table of the results. So when we first looked at 5.5, and like David did an implementation, whatever, 2 years ago, 3 years ago, the implementation wouldn't work. We didn't realize that it wouldn't work until someone on my team says, your plan will fail, and it took him like 15 minutes to explain why. So the issue is that it's actually quite hard to do 5.5 without doing 8028. So I suspect that 5.5 actually appears to work in your testing on macOS and Windows, unless they like really did source test. I guess my point is it's really hard to do 5.5 correctly and keep it working if you don't have source tests. So I suspect that it's probably possible to construct some test cases where Mac OS and Windows will fall over. For example, one thing that they might fall over is if you send an RA for R1, you want that to be preferred, then you make it go away, and then you send an RA with a lifetime of 0, and then you send a new RA with a lifetime that's non-zero. I suspect a bunch of stuff will fall over and it'll stop working.
But
so
we,
that's
kind,
another
we kind of did that, right, David? We deprecated R1, that we brought it back.
lifetime of 0. Yeah.
Yeah.
So anyway, I suspect that there are things that will cause them to forget. So it'll be good, not like, I think we've asked the people who know this implementation several times, Tommy, and Ted, to figure out why this works. I don't think they ever looked, but I think before I know that you tested a bunch of cases, those are useful, but I suspect that there are still corner cases that you haven't found.
So basically, I expect next IETF at Saturday morning, see you at our hackathon, helping us with test cases.
My code doesn't work. That's
no, we know. What I'm interested in, you're saying that you suspect there are cases when those successfully working operating system would fall over, and secondly, you think they should be doing 8028. So I'd like to know what we need to change in our test cases to cover those corner cases, because whatever I was able to come up with was tested, right? Obviously, maybe I missed something, right?
Yeah, I don't know. All I know is that the state that you need to keep for 5.5 is actually basically the same state that you need to keep for 8028. Otherwise, it doesn't work. So yeah, maybe the implementation is correct. They just didn't do 8028 because they didn't think it was necessary, but it's possible so that they don't have the state.
So that's basically, that's basically observation,
so, yeah, we
right?
have to try and trip them up somehow, yeah.
Okay, so let's move on. Chen Hao, it's your turn.
Can you hear me? Hello?
Yes, please go ahead.
Okay, thank you. I'm going to talk about considerations of gradual IPv6 only deployment in 5G mobile networks. This is our first discussion on this topic here. We have been trying to deploy IPv6 only technology in our 5G networks. This draft captures our key considerations during the deploying process, and this is a working draft that will undergo further development. Next slide, please.
Please control your time and focus on the key points.
Okay. So IPv6 has been widely in mobile networks, especially in China. It's now around 67.5% according to the data available at this website, and it may be continue to show an upward trend. So we consider to migrate networks to IPv6 only. Operators have begun experimenting with deploying IPv6 only approach in their mobile networks, but there is no 5G deployment experience available here. This document will describe the approach using IPv6 only technology on user plane in 3PP 5G networks. It contains 5G system IPv6 only architecture on user plane, deployment challenges, and deployment solutions. Next slide, please. Here we talk about some terms related to the 5G systems using plain language. The UPF is a critical component in 5G core network that handles user data forwarding and processing. It acts like a gateway between 5G devices and external networks. including the IPv4 address and IPv6 prefix assignment function. The PTU session is the logical connection between 5G device and data network, enabling end-to-end data transmission. So it's like the context of the connection. For example, if the PTU session type is IPv6, the UPF will assign as IPv6 prefix to UE, and the UE will using the IPv6 to access the internet. Next slide, please. Another one is roaming. The roaming allows a 5G device to connect to a visited network while maintaining the seamless service. Here we have 3 scenarios as shown below. Scenario 1 is non-roaming. Here the UEA connect to the home network 5G-CA and get IP configuration from the home network 5G-CA and access internet through the 5G-CA. The scenario number 2 is roaming with home routed. In this case, UEA connected to the 5G-CB and it gets IP configuration from the home network 5G-CA and access the internet through the 5G-CA. The scenario number 3 is roaming with local breakout. In this case, the UEA connects to the 5G-CB. UEA gets IP configuration from 5G-CB and access the internet from through 5G-CB. These are 3 scenarios. Next slide, please. So we will have 3 architectures, each based on each scenario. In scenario 1, we will deploy have net64 function, DNS64 function, and select function in the home network. In the scenario 2, we will have select function, net64 function, and DNS64 function in the home network. But in the scenario 3, we will have net64 and DNS64 function in both visited network and home network. That's the point we want to point out. Next slide, please.
Chen Hao, you may have to accelerate a little bit, otherwise you may not be able to go through all your slides.
Okay. So based on our practice, for a larger size mobile network operators, it's very difficult for operators to deploy IPv6 only capabilities across the whole network. So there is a transition period that the IPv6 only capability is deployed gradually. So we need a time to deploy this function one by one. Next slide, please. We also have some UE challenges. We have tested a significant number of terminals that had not enabled select function, including some smart devices, and moreover, Apple's iOS in China doesn't not enable select functionality, but it does support that function. Upper layer challenge is about the existing layer 3 and layer 4 content building rules based on IPv4 address will no longer be effective because they have using the IPv6 address. Next slide, please. And there I also have this DNS64 configuration challenge. After enabling the DNS functionality, there is an increase in the processing load due to the additional handling of the IPv6 queries, and the DNS64 conversion which consume some device performance. The extent of this performance demand increase depends on the scale of IPv6 queries. Once the DNS64 functionality is enabled, DNS resolution requests from both IPv6 only and dual stack users will be processed by the DNS64 server. So even IPv4 resolution requests from dual stack user will be treated as if they were from IPv6 only users. Next slide, please. So we have some deployment solution. One is called IMEI configuration at network side. I think this is not in the scope of IETF. So next slide, please. Another possible solution is to use option 108 method to allowing UE to choose whether to join the IPv6 only environment. Additionally, we need a method for configuring DNS64 server addresses needs to be considered. However, in practical deployments, core network support for DHCPv4 functionality is optional and may not be applicable to all networks. Next slide, please. So we want to propose a possible solution is to transmit a prefix 64 and the DNS64 address information through the RA option. In 5G system, RA is used to divide the IPv6 prefix in the Slack, which is a mandatory functionality. Transmitting this information through RA is also a favorable option. Next slide. So we want to get some feedbacks and comments, and then we will develop the solution based on RFC 8106 and RFC 8781. Thank you.
Jen Linkova, co-author of 87, whatever, prefix 4. So thank you very much. I'm glad to hear there are mobile operators who are interested in doing prefix 4. So instead of DNS64. So I'm curious, as far as I can understand, and I'm no expert in 3GPP stuff, the current standards does not current standards do not mention a prefix 4 at all. So are you working on changing that? Are you interested in getting the change, if I read your slides correctly?
Yes, I'm very interested in getting the change.
Okay, thank you.
Okay, thank you, Chen Hao. Let's move on. Chong, you also have to control your time.
Okay, I'm Tony from China Telecom. I'm presenting the draft of basic requirements for IPv6 only provider edge routers. Next slide, please. As we know, with the rapid growth of IPv6 traffic gradually in some networks, there is a growing need to consider the transition from IPv6, IPv4, and IPv6 dual stack network to IPv6 only network. Running an IPv6 only network would reduce the operational cost and optimize operations as compared to dual stack environment. The PE devices are the edge routers located at the boundary between an IPv6 only network with other networks, such as the IPv6 only access network or other customer networks or other IPv6 networks in a multi-domain environment. This document describes the basic requirements for IPv6 only provider edge routers, aiming to provide a general recommendation for vendors and network operators for IPv6 only network deployment. Next slide. In this page, the figure 1 shows an example of multi-domain underlying network. We can see that the location of the PE devices. We can see that the PE plays an important role for IPv6 only deployment to enabling the service, the function of IPv6 as a service. And besides this, it also in networking with other neighbor networks. The figure 2 shows the key interface of the PEs. The PE is connected with so many kinds of devices, such as the UE, the CE, or IPv6 routers, IPv4 routers, or other provide edge devices. So this document outlines the necessary functions and capabilities that PE devices should persist in a multi-domain IPv6 only network environment. Next slide. I will introduce some requirements of the PE routers. The first one is the IPv6 base protocols. The first point is IPv6 addressing. The second point is IPv6 routing protocols, including IGPs and EGPs. The PE routers must support at least one IGP protocols, but this document provides no specific recommendation in this regard. Besides this, PE devices shall support MPBGP. The router shall use MPBGP to exchange routing information with other AS. The third point is PE devices must fully support ICMP V6. Next slide. The second requirement is MPBGP attention. The PE routers must support the new route types defined for the MPBGP attention related to SMAPLEO, which is defined in draft IETF IDR MPBGP attention SMAPLEO. These route types are used to carry information about the mapping between IPv4 addresses and IPv6 addresses. The third point is the attribute support. PE devices need to support the specific MPBGP attributes for IPv4 and IPv6 mapping. Advertisement defined for SMAPLEO. The support PE routers should be capable of currently advertising SMAPLEO related routes to other routers in the network. Next slide. The third requirement is the encapsulation and translation. PE devices must support the encapsulation of IPv4 packets within IPv6 packets. In addition, PE devices must support the stateless translation mechanism as defined in RFC 7915. Next slide. The next requirement is stateful NAT64. They shall support the stateful NAT64. It is important to providing backyard compatibility and enabling the continued use of IPv6 applications. Next slide. We also can have a consideration of configuration and management of the PE routers. The PE routers shall accept a centralized policy scheduling from the network controller and implement automatic configuration through the netconf protocol or YARN models. The PE routers shall support a syslog and SNMP trap alarm mechanisms. Next slide. The SRv6 functionality considerations are mentioned in this document because SRv6 is a form of segment routing that use IPv6 as the underlying technology. In a multi-domain IPv6 only network, SRv6 can be used to provide efficient traffic engineering, simplified network operations, and support the new services. So SRv6, so the PE devices shall support SRv6 endpoint functions, policies, and related routing information exchange as optional. Next slide. In conclusion, PE devices play a virtual role in connecting different networks and facilitating the exchange of traffic. It's essential to clearly define the requirements for the PEs for building a stable and reliable IPv6 only network. This draft is a starting point, so any comments are welcome. Next slide. The next version will be reversed based on the comments from Brian and Jane. Thank you. That's all.
Thank you, Kong, for the presentation. I think very broadly, you're authoring a draft here which is designed to talk about a very generic method or a very generic mechanism. So it's a very broad topic, creating an IPv6 only network. I think you have perhaps been too specific with some of the suggestions. So format 6, for example. And it also kind of exceeds the remit there, really. I think once you start recommending using Yang models for configuration, I mean, that's totally outside of the kind of scope of a set of standards that you would try and enforce for an IPv6 only PE. SRv6 has no place in there. And the reason for that is just because it's one of many different ways to do an IPv6 only network. So calling out one specific protocol is the antithesis of effectively the aim of the draft. So I would probably suggest it needs a significant rewrite with a focus on generic mechanisms and generic methods. There are some things in there that are probably quite sensible, I'm sure, to be specific about. But yes, we have to be very careful not to make this too confined to one person's idea of what an IPv6 only PE should look like. But thank you for your presentation.
Thank you.
Jen Linkova. Yes, I actually would like to second what been just said, and specifically about management. I'm not sure. I think the very good thing to recommend in documents like that would be not specific mechanism for management, but instead saying devices must support management over V6 only. Because quite often you can see you can do V6 only network, but you cannot manage your devices until you have IPv4 address. So this should be probably explicitly mentioned in the documents like that.
Okay, thank you.
Ron Bonica, HPE. I'd like to amplify something the last two speakers said, and it's really a methodological issue around requirements for any class of device. There are two ways to write the document. One is to look for requirements that every operator on the world would agree that we need. For instance, in an IPv6 PE, we definitely need IPv6. We definitely need ICMPv6. We definitely need so many other things that came out of 6-man. Then there are other things that one operator might want and another operator not so much. We talked about management. We talked about SNMP traps. SR is another example. One operator might not need traffic engineering at all. He doesn't need SR. He might not be doing VPNs at all. He doesn't need SR. Another operator might want to do his traffic engineering with IPv6 over MPLS. He might need MPLS. So we need to restrict the document to only those things that all operators will need. RFC 8200, RFC 4443. I can think of a bunch of others that they would need, but we have to be careful to leave the others out.
Okay, thank you.
And by the way, no hats.
Thank you, John. So let's move on to the last. Nick.
All right. So in the context of this, I'll be playing the part of my student, Ryan Reardon. He did all of this work. Next slide. So we went to find what the current status of CLAT major non-mobile operating systems was, because we couldn't find a definitive list of that anywhere. And as a stretch goal, we decided we wanted to maybe test a little bit of the performance as well, really basic stuff, and document all of it. And the draft that I just published, because I missed the deadline by a day, is now up, and you can read it as the result of that. Next slide. So this is really short, by the way. If folks get a chance to take a look at it, and I do realize that I just published it, I would be interested to know, as we've documented the sort of basic things that we found, by looking for the last couple of months, what's missing from it. We have a pretty, we try to break down the major operating systems, and again, we're looking only at non-mobile. So there's no, iOS, there's no Android or anything like that in there. This is specifically like desktop and server class operating systems. And to that end, is that all that we should include in there? What shouldn't be in it? What's missing? And most importantly, is this useful? We found it fairly useful, and we continue to sort of add things to it. But I would be interested in what other folks think. If having this listed somewhere as a current state of the art, we used another document sort of as a basis that did something similar, just because why we create the wheel. But again, is it useful in this context? And if so, do you want to contribute to it? And that's basically it.
Jelinkova. So how do you see this document progressing? Because the problem is it's like talks about snapshot and the given period of time. And I do hope that quite soon it will be obsoleted, because one certain operating system promised to implement CLAT, and we're all patiently or not so patiently waiting for it, right? So the question is, should it be a draft which will be eventually published and might get obsoleted as soon as it gets out of ISG, or you want to maintain it as something else, maybe not necessarily as a draft? It's definitely very useful information there. I'm just not sure that ID, like Internet Draft, is the right place for it.
Yeah, it's definitely a snapshot in time. And I kind of waffled back and forth on how we should do that. I did find a couple of other documents that were kind of similarly focused. I don't necessarily have a strong opinion on if it should keep progressing further. I do think that we will continue to add data to it. And then when that data expires, then we can change it. It doesn't necessarily need to become something else, and maybe it becomes a different kind of document altogether that's not even a draft. But using some things as a as a basis to sort of form it around that were kind of similar, I thought, okay, well, there's precedent for stuff like this, so I would leave that to the group as to where we go forward with it, or if we don't.
So to be honest, if I were a random engineer looking for CLAT support state, I would go to Wikipedia. So maybe what you want is actually update that info on the wiki page and keep it up to date there, because I suspect a lot of people would be looking there first before going to RFCs, because I've heard from operators community that the kind of do not really like reading RFCs. So if your target, like basically, yeah, what is your target audience for this?
That's a good idea. I like that idea. Thank you.
So this is Xipeng without any hat. I would like to say that I find it interesting and useful because CLAT is already widely deployed on the mobile side. It would be really nice for it to also be widely deployed on the fixed side, because personally, I believe that in the fixed world, there are too many options. It would be really nice to actually convert to a few options so that it actually make the deployment support, etc., easier. Otherwise, if there are too many options, sometimes it confuses the people who want to deploy.
So one thing we did notice was that when we wrote it all out, basically all the major operating systems are supported except one, and that one has been working on it. And so once that happens, I don't foresee. I mean, sure, random Linux versions and things like that are going to change. Really, Linux is the most complicated part of it because it's whatever people want it to be, right? So that's the part where I could see it being sort of fluid.
Yes, I guess this is the point that Jane made, but I am thinking in addition to the host, maybe the CPE, for example, the home gateway, will they also, I think that at least this will raise people's awareness and encourage people to, pay attention to it.
Tommy Jensen, unaffiliated with the thing you're putting pressure on. So I do think this is very interesting. And this is one of those cases where I really wish that working groups had dedicated wikis, because that's exactly the format for this kind of information.
We do have this.
Yes.
And we could put it there.
I would suggest we put it there.
We have been using that wiki for other things. There's no reason we couldn't add stuff like this to it.
Well, I should visit it sometime. So
you really should spend hours and hours on it.
Make me feel bad. So yes, and I think it would be awesome to have a paired study for PLAT implementations. For example, I would love to know things like, does everyone actually support setting network-specific prefixes? Because various people told me that they weren't able to, and I wasn't able to verify that claim. But if that's really the case, that would be interesting information.
So I can tell you, it's not in our draft, but that is an accurate statement.
So, because that's one of those things where the well-known won't let you do 1918 space translations. And that's a thing that shocked a lot of people that I was talking with about. Anyway, I think this is very useful. Thank you. And let's keep it updated as living information.
Okay.
Jan Linkova again. First of all, following up on this, there is a wiki situation, right? I actually meant like well-known public Wikipedia. But if you have a wiki which nobody, even this group doesn't know about, we probably need to do something about that. And again, our audience outside of this group would definitely never find it until we actually either start putting links from like wikipedia.org CLAT page to this, or just maintain that page, right? So yeah, I think we need to think about how to communicate it, make sure our message is received by the people we wanted to get this message to.
Yeah, we can definitely do some more messaging on the wiki. I think the last stuff we put on the list about it was when we first started using it, to basically document our chair meetings. And I don't know that I ever said anything else out about that, but it's definitely available to us. It's robust. It's easy to edit. This is a good idea to use it more.
Second point I'd like to make, actually, point 1.5, the queue is closed and we kind of ignoring it. So I don't know if you really want it closed or it's just an oversight. Anyway, queue is building up anyway. So what I actually realized when Tommy mentioned using network-specific prefix versus well-known prefix, in context of Jordi working on bringing something to full standard, I'm thinking, do we want to reconsider that must not translate private address space using a well-known prefix? Because all implementations I've seen actually ignore that must. So I believe it must be a reason for us to have this must, but I don't know, is it actually harmful? What's gonna get broken? And like, do we want people to start using network-specific prefix only because they have V6 for only internal destinations and they have V6 mostly segments? So maybe it's something we might to discuss in the context of standardizing that.
Yeah, that's a great data point too.
Chung Feng of China Telecom. Actually, I'm very interested in the IPv6 only deployment in fixed network. This work is very close to that. So I support this work. I hope that can progress in the future.
If you have any data to add to it, send
Sure,
it over.
I will try my best to add some data, right?
What's that?
You mean I give some data?
If you have anything that we can add to it,
Oh,
we'll
sure,
add it.
sure.
Yeah, just send
I will
it
try
over.
my best to data. Okay.
Okay, Gabor.
Thanks.
Hi, I'm Gabor. Just a short comment. I'm online. You don't see me. Okay, so just a short comment. As far as I know, Wikipedia policy doesn't allow the publication of original research. So if you want to publish it on the public Wikipedia, you must first publish on the Wikipedia wiki page of V6OPS, and then you can refer to it and you can copy it there.
I did not know that.
Thank you.
Thanks.
Bob, you want to say something? You just joined the queue. Well, if no, I think that this is the end of the V6 op session. Thank you very much.